Good morning, Ovid Middle School students. What we're going to try to do today is going to use in lesson 17 our unit rate as the scale factor. So the scale factor is how much something grows or shrinks, and we're going to determine if shapes are proportional or not based off if they have the same proportional growth or ability to shrink down the same way all the way throughout the problem. So for example, we have a original sketch, and this guy wants to make it into a sticker. We can read from up there if you'd like to, but he wants to know if that's going to be proportional. So what we're going to do is we're going to make a table of all the data. Now, I want corresponding measurements to match up, so I labeled like this measurement A for each picture. The height is measure B in each picture, and so on. So the A's are going to match up with the A's, the B's will match up with B's, C's with C's, and D's with D's. Okay, so my original is going to go here. That's my X column. My original A, my original B, my original C, and my original D. And then I put my sticker, the newest picture. And I have the measurement for A, B, C, and D as well. Now, what I'd like to do is take a Y value divided by an X value in a table, just like we have for many, many lessons. And I want to see if we get the same measurements throughout. 2 divided by 1, 2 divided by 1, 1.5 divided by 0.75, 1 3/4 divided by 7/8. You're going to get 2 for all of those. So I would say the sticker is proportional to the original because all the measurements are 2 times larger. So as we went from the first picture to the second picture, we do have a proportional relationship growth. The scale factor is 2. It grew twice as big. Okay? So how can we check for that proportionality? Record the measurements of the original on the X side of the table and record the corresponding measurements of the new image on the Y side of the table. It's kind of like what we just did. And then divide Y by X for each pair of measurements, and if they all grow or shrink at the same rate, they'll be proportional. So the division answers that you get from that table are the scale factor. So our scale factor, remember from our problem over here, was going to be 2. It was twice as big. All right. Similar thing, we're going to use our original information, that original sketch from page 72. Remember the kid's original drawing. We're going to use that measurements as my original. And now, this is the measurements of an app icon that they want to do for computer or tablet. All right, so I have all my original measurements wrote down like I did in the previous problem. And I still corresponded them for the A, the B, the C, and the D. And now, the app icon, I have a 1/2, a 3/8, and a 7/16. Now, since this is in decimal form, I converted 3/8 to decimal form. 3 divided by 8 in your calculator gives you 0.375. Now, if I took my Y values divided by X values, remember we always take Y's divided by X's, Y's divided by X's all the way through. 1/2 divided by 1 is just going to be 1/2. Anything divided by 1 is itself. 1/2 divided by 1 is a half. If I took my 3/8, or what I call the 0.375, and divided it by 0.75, I get 0.5, also known as a half. Now if I took 7/16 divided by 7/8, I get 1/2. So the app icon is proportional to that original because each measurement is half the original size. The scale factor is 1/2 because the app icon is half of the original size. And I can do this with similar pictures here too. It says use a scale factor of 3, which means I'm going to get 3 times larger to create a scale drawing the picture below. Picture the flag of Columbia. If I say that this is going to be 1 inch tall and 1.5 or 1.5 inches across, then each of these little bars are only 1/4 inch tall. All I have to do is multiply each measurement by 3, and it tells me what the new measurements will be. So if I took my 1 inch measurement here, times it by 3, the new picture is going to be 3 inches. If I take 1/4 times 3, so each of those were 1/4, that's going to give me 3/4 for those measurements. And if I took my bottom measurement, 1.5, and I times that by 3, I get 4.5. So if the scale factor is going to be 3, I just multiply each measurement I know by 3. Scale factor of 1/2, similar concept. If I have this flag again, 1 inch by 1.5, and each of those are 1/4. And if I want half of all those, I just multiply them by a half. So times 1 by a half, times 1/4 by a half, 1.5 by 0.5, which is also 1/2. So you see, the 1 inch turns it now into a 1/2 inch. 1.5 turns into 0.75. And those 1/4 inches, 1/4 times 1/2 gives you 1/8 for each of those. All right? So this is an important point here. An enlargement will have a scale factor greater than 1. So it can get twice as big, 3 times as big, 4 times as big, whatever. As long as it's bigger than 1, it's going to be an enlargement. And a reduction will have a scale factor of less than 1. So any fractional amount, I don't care if it's like 7/8 or 1/2 or 1/3, anytime you have a fractional amount like that for the scale factor less than 1, it's going to be a reduction. All right, let's take a look here. It says your family recently had a family portrait taken. Your aunt asked you to take a picture of the portrait using your phone and send to her. If the original portrait is 3 feet by 3 feet and the scale factor is 1/18, draw the scale drawing that would be the size of the portrait on your phone. So the picture is measured in feet, but on your phone, things aren't going to be measured in feet because your phone's a lot smaller. So what I'm going to do, before I start, I got my 3 foot by 3 foot picture here, but 3 feet is also known as 36 inches. Remember how 1 foot equals 12 inches? So 3 feet equals 36 inches. So I'm going to use inches because in my final measurement on my phone, I'm going to probably measure that in inches. So now, if I know the real measurement's 36, and the scale factor is 1/18, it's going to be 1/18 that size. So 36 times 1/18, put the whole number over 1 times 1/18, and I can cross cancel, divide them both by 18, and you get a 2 and a 1, and you get 2, so 2 inches. So really, it's a 2 inch by 2 inch picture when it's on your phone there. Exercise 3, John is building his daughter a dollhouse. It's a miniature model of their house. The front of their house is a circular window with a diameter of 5 feet. Right there in our picture you can see. If the scale factor for the model house is 1/30, make a sketch of the circular dollhouse window. So 5 feet, kind of like we just did in the last problem, I'm going to turn into inches. 5 times 12 gives you 60 inches. So 60 inches times 1/30, well, I can divide those both by 30, and I get down to a 2 and a 1, and I get 2 over 1, which is just 2 inches. So that window in the dollhouse is actually going to be just 2 inches. All right, here's some other sample problems here for you. Want to find the scale factor. All right, so there's my original, and then the new version of that. You always take your new, your y value, divided by your x value. So 5 divided by 3, if I do that, I get 5/3 or 1 2/3. So its scale factor, it is bigger, it's an enlargement, and my answer is greater than 1. It's 1 2/3 the size bigger. All right, now this one's a little trickier. The original is 24 centimeters all the way across for the diameter. But they just gave you the radius here, so be careful. Cross off that 6. We're going to make it stretch all the way across, so we double the radius, and now it's 12 for a diameter. All right, so now I got all the way across compared to all the way across the circle. So I take my newest information, my 12, and divide it by the old information. And 12 divided by 24 is 0.5, or 1/2. And you guys obviously can tell that the ball has shrunken down, so something less than 1 does make sense here. All right, we'll pretend that we're going to do the scale factor here. And if I was going to do a scale drawing of this, the scale factor is supposed to be a 3. So whatever it is going to be 3 times bigger. So for example, this envelope, if I was going to redraw it, 1 inch times 3 times bigger is going to be 3 inches across the bottom. Here, if the scale factor is 3/4, I'm going to have a reduction, very small reduction. It's not very much difference, but it's 3/4 the size. So if I think, oh, this was originally 4 inches, well, it's going to be smaller because its scale factor is 3/4. It's less than 1. So I take 4 times 3/4, so I put 4 over 1 times 3/4. Do our cross canceling, we get 3 over 1, and now it's only going to be 3 inches tall instead of 4 inches tall. And number 6. We have a situation where this girl's building the sailboats with her father. And they give us the information, and I drew out the right triangle here. I have a height of 8, and then the bottom, the width is 6, and then that long diagonal is going to be 10 inches. So I labeled the height as A, the width is B, and that long diagonal is C. And I drew a little miniature version of it because you're going to shrink it down, you're going to use a scale factor of 1/4. So really all you have to do is take each measurement, each original, and times it by 1/4. So 8 times 1/4 should give you 2. 6 times 6 times 1/4 gives you 1.5. And 10 times 1/4 gives you 2.5. So anytime you know the scale factor, just take the original times the scale factor, and it tells you the measurements. And since this was going to be smaller, I went from having an 8, a 6, and a 10. Now I'm down to a 2, a 1.5, 2.5. yes, that does make sense. So, all right, well, thank you for watching, and hopefully you do well on the practice in Schoology.